Yeah, hello everyone. Now the slides are visible, I think. Hello, audience.
Yes, sir, it's visible.
Yeah. So we'll start. So last period, so we were discussing the different operating systems. So different operations of operating systems are the program management and resource management, and the last one is security and protection. So in the last period, we were discussing the program management, where the program, so the word program refers to the set of instructions. So here all the programs will be there in the first in first out queue. So the OS will maintain a first in first out queue, and all the programs will be stored in the queue. And the head of the queue, I mean the program which is there, that of the queue will be given for the scheduler, and the scheduler will give the program to CPU for execution. So here I've given the example of a queue. So where this P1 and P2 and P3 are the programs which are there in a queue. And of course, the P1 process is at the head of the queue, and P3 is at the queue tail. So the P1 program will be given for the scheduler, and the scheduler in turn gives this P1 to the CPU for execution. So once the P1 is executed for a particular timestamp, again the P1 will be placed at the tail of the queue, and next program that should be given for scheduler is P2. So similarly, after P1 and after P2 and after P3, like this, all the programs will be executed only for a limited amount of time, and that we call it as timestamp. Okay. So why this happens? Because the CPU needs to give fair service for all the programs. Hence, for each and every program, the OS will attach a particular timestamp. So only for that amount of time, all the programs will be executed. So for example, like in the last period, like we have taken the timestamp as 5 seconds or 5 milliseconds, let's say, then only for 5 milliseconds of time, this P1 is executed. And after the execution of P1 for 5 milliseconds, this P1 will be preempted. And so this P1 will be placed at the tail end of the queue. And after P1, the next program, P2 will be coming at the head of the queue. And also the same program P2 will be executed for 5 milliseconds. And after this P2 executed for 5 milliseconds, again it is placed at the tail of the queue. And after P2, next P3 will be coming at the head of the queue. Again, P3 will be executed for 5 milliseconds of time. And after P3, again the P3 is preempted and placed in the tail end of the queue. And again, now it is a turn for P1. So hence all the program will be executed only for 5 milliseconds of a timestamp value. Hence, the CPU can give its time for all the programs, right? On the first one, first out basis. Yeah. So once you write a program, it is converted into a process, right? Again, definition of process is executable form of a program. So what is a program? Basically, program is nothing but the set of instructions. Again, any CPU will not be able to execute the program if I am not able to convert the program into process. Okay. So once we convert a set of instructions, so-called program, into a process, so this process can be given for the execution by the CPU. So what is a process then? So this process is nothing but executable form of a program. Means, say for example, if I write a C code, say hello.c, okay. Suppose if I write a C code, so by name hello.c, so then this C code, so called the high level language, will be given for compilation. So what is compilation? Basically, compilation is the process of conversion of high level language into the executable form or .exe file. So this .exe file can be given for CPU to execute. So the process of conversion of high level language in terms of executable file, we call it as compilation. Hence, any CPU will be able to execute the process and not the program. Okay, so these programs are maintained in the OS in the form of a queue. So where is that queue? Here is that first in, first out queue where CPU will be able to, the OS will be able to maintain so many programs. Okay, so many programs in a queue, where this queue is having the head end and the tail end. Okay, so these rows, say like row 1, row 2, row 3 are nothing but the queues. Okay, and if I see the first row, means here P1 will be at the head of the queue and P3 will be the, like P3 is the process, so which is at the tail end of the queue. But here it is. Okay, again for second iteration after execution of P1, so now P2 will be coming at the head of the queue, and after execution of P1, this P1 is placed at the tail end, and after execution of P2, next turn to be executed is for the process P3, and so on. Okay, yeah, so the program are maintained in the OS in the form of a queue. And if you see the process like AMD processor, Intel processor, ARM Cortex processor can execute more number of instructions in less time. Okay, why? Because our CPU will not be executing only just a single program. Okay, means I'll be maintaining n number of programs in the queue, and I'll be allocating a particular timestamp for each and every process. Hence, the CPU will not be kept idle. Okay, so executing more instructions, OS can give good user service. So by the execution of more number of processes, our OS will be able to give good service for the users with effective mixing of execution of several programs. As you can see here, like in the queue, like here we have stored so many programs. Okay, so we have a effective mix of all the programs in the queue. Okay, whereas where the CPU will be giving enough time for each and every process. Hence CPU can attend for all the programs. Okay, so next operation of OS is resource management. So again, like we have seen the examples of this resource. So what are all the resources in a computer system? So various resources of a computer systems are say CPU time is the main resource, CPU time. So then RAM, primary memory, are also called as main memory. So then network throughput, electrical power, input devices, output devices. So here, suppose if any process or any program is requesting for a resource for its execution, so then how our operating system will be able to allocate the resources for the processes or for the programs, and after the use of resources, how the OS will be able to deallocate those resources. Okay, so for that we have something called as a resource table. So here on the slide, what we are seeing here is called as a resource table, like which has got so many parameters. So called the resource name is there, and we have the resource. Is it audible? Hello? Is it audible?
Yes,
Are you
sir.
listening?
Yes, sir.
Yeah. So this particular table, so what we are seeing on the slide is called as a resource table. So where we have mentioned all the resources, all the possible resources that are being connected to a system. So once the system or the computer is switched on, so the OS will check so what all devices are being connected to it. Okay, so for example, so once we turn on the system, means you can see here, so the resource name is printer 1, printer 2, printer 3 are being connected to a computer system, and we have here the disk 1 and disk 2, right? So this disk 1 and disk 2 are of the class the disk, and we have CD writer, like that's been also been connected. So we have here 3 printers and 2 disk and 1 CD writer is being connected. So we have the class of these resources as well as the starting address where these resources are being stored is also being mentioned in the resource table, and allocation status. So what is this allocation status is, so whether these input devices, output devices, so-called resources are available or not. So whether these resources are being allocated to any process, so whether these are free or engaged, these parameters will be indicated in the allocation status. So for example, here the printer one, so which is of class the printer, having a starting address of 101 is being allocated to process P1. Similarly, like if I see the printer 3 of class printer, like having starting address of 103 is being free here. Okay, so this printer 3 has not been allocated to any processor program. Hence, it is showing as free. So whereas disk 1 of class disk, like having starting address of 201 is allocated to the process P1. Okay, so this we call it as a resource table, where upon switching on of the system or the computer, the OS will maintain the resource table where we have the resource name and the resource class and the starting address of those resources, as well as the resource allocation status is been maintained by the operating system. So then this table is called as resource table, that is formed by the OS upon the switching on of the system. So if a user or any process, any program is requesting a resource, so then what OS will do is OS will consult this RT. So what is RT? RT is the resource table. So what I'm showing here. So once any process is able to request for any resource, then OS will consult the this request table and check whether the resource is available or not. Suppose if the resource is available or if the resource is free, so then that particular process will be allotted a resource. And if the resources are not free, so then the process has to wait until the resources are being freed. Third point is, say resource table is constructed by the boot procedure by sensing the presence of a input and output device in a system. Like as I said, once we turn on the system, means the OS will be able to construct this resource table by sensing what all devices are being connected to the particular system. Okay, so by sensing those input and output devices, the OS will be able to form the resource table. Hence, this resource table will be constructed at the boot procedure. So what is a boot procedure? Booting is nothing but loading of OS from ROM into the processor or CPU. So that we call it as the booting process. So this resource table will be updated by the OS to show the allocation and deallocation of resources made by it. Okay, so once we have the allocation of resources to any process, the the status of the resource will be updated in the resource table. Okay, so as to educate the operating system. So once we have any sort of allocation and deallocation of these resources to any process, the particular resource table will be updated. Okay, and regarding the resource management, so what is resource management? Resource management is one of the main operation of operating system, where the OS will be dealing with allocation and deallocation of the resources to the process. Okay. The next slide. Yeah. So after this, next heading is the popular resource allocation strategies. So we have basically two types of resource allocation strategies. So the heading is resource allocation strategies. So basically we have two types of resource allocation strategies. So one is, so we call it as resource partitioning, and second one is pool-based resource allocation. So what do you mean by the word resource allocation? Like I said, resource allocation and deallocation is nothing but one of the main operation of operating system, where the OS will be able to allocate the resources, so-called CPU time, or the processor, CPU time. So then input devices, output devices, memory, and so on, for the requesting process. So whichever process or whichever program is in need of some resources, Okay, so for those process, OS will be able to allocate the resources, as well as after the use of those resources by the process, the OS will also uh, it will also deallocate the resources so that the same resource can be given for the other requesting processes. Hence, the allocation and deallocation of resources is done with the help of RT. So what is RT? RT is the resource table, what we saw in the last slide. So this resource table is prepared when system is booted or when you switch on the system. So then OS will sense. So whatever the input and output devices that are being connected to the computer or to the computer system, so that will be sensed and the OS will prepare the resource table. And that resource table will be handed over to the OS. So this OS will keep on updating this resource table. Its fields are, so we have resource name and we have the class of resource and we have the starting address of the resources and the allocation status, right? And we have seen the resource table in the last slide where we have where we had when the different fields were there, like as in here. So we have the resource name and we have the resource class and we have the starting address of resources and we have the allocation status. So this resource table will be formed once you boot the computer system. So now dealing with the two types of resource allocation strategies. So basically we have here two types of resource allocation strategies. So one is resource partitioning and second one is pool based resource allocation. So now let us deal with the resource partitioning. So here what OS will does is, here OS will decide, like in the first place itself, OS will decide so what all resources that has to be allocated to each and every program. So here, based upon the priorities of the programs, the OS will be able to decide for what all processes I need to allocate the resources and will divide the system into so many partitions. Again, the word partitions refer to the collection of resources, right? So what is the basic point in resource partitioning? So we have some collection of resources, and based upon the programs that are being requesting the OS for the resources, the OS will allocate the priorities for each and every program, and based upon the priority, the OS will be able to allocate the resources for the programs or for the process. So the simple example what I can quote here is, suppose we have 1 GB of main memory, or if we have 1 gigabyte of RAM, so then system will be able to divide this into 1000 equal parts. Okay, each part of 1 MB size, and each and every time a process asks for the memory, okay, so we can allocate 1 MB of memory. So here what we are doing is, we are just partitioning this 1 GB of RAM into 1000 equal parts, where each part of memory corresponds to 1 MB. And upon the request by the processes, the OS can allocate 1 MB of memory, right? This is the best example for resource partitioning, where we have divided the 1 GB of memory into so many parts. Okay, each part of 1 MB size. Okay, and OS will be allocating this 1 MB of memory for the process that is requesting for the memory. So the advantage of this resource allocation, I mean resource partitioning, is like it is easy to implement and it is much more faster, because the main operation involved here is to just divide this 1 GB of RAM into 1000 equal parts. Hence the partitioning is easy, as well as allocation is also in a fast manner. So what is the main demerit of this? Okay, so what is the main disadvantage of this is, suppose if our code or a program is hardly using 10 KB of memory. So, but here I have allocated 1 MB of memory for each and every process, but our process needs only 10 KB of memory. Okay, like in this case, this is absolutely the waste of memory. Why? Because available memory is 1 MB, and in the available 1 MB of memory, here I am just using only 10 KB of memory. Hence, it is a waste of memory. Okay. Or the second case may be, suppose if the program needs more than 1 MB of memory. Okay, like in that case, here I am just allocated 1 MB of memory. So, but the program is in need of more than 1 MB of memory. So then our program will not get enough memory for its storage. Okay, hence this is the two. I mean, like these are the two disadvantages, like in case of resource partitioning. Second one is pool-based allocation. So what are the points with respect to pool-based allocation of resources? Like here, the OS will allocate resources from a pool of resources. So we have something called as a pool of resources from which our OS will allocate the resources for the particular processes. Suppose if the program asks for memory, right? So the OS will allocate a small amount of memory based upon the request. And if the program is in need of more and more amount of memories, means OS will be keep on allocating the memory based upon the request by the processes. Okay, so this kind of approach we call it as pool-based allocation of resource. And the main advantage of this pool-based resource allocation is like it achieves more efficient use of resources. Why? Because as and how the process demands for the resource, so-called memory, the OS can go on allocating the memory. Hence, it achieves more efficient use of resources. And the main demerit, the main disadvantage of pool-based allocation of resources, OS will be able to consult the table and allocate the resources if it is free. So for each and every request for the memory, the OS needs to consult, okay, or observe the resource table and then go for the allocation of resources. So the OS needs to maintain so many entries. Why? Because here we have so many requests by the processes for the memory. Hence, the number of entries in the resource table will be more. Okay. So less overhead of allocation and deallocation of resources will be there. So we have here these points for the pool-based resource allocation. And earlier, like we have seen the resource partitioning. Okay. So from examination point of view, like this question has been asked in the previous 17 series examination. Hence, you can observe these two types of widely used resource allocation strategies. So one is resource partitioning, where we have the collection of resources, okay, and we can divide the so many resources among n number of processes. And second one is pool-based resource allocation, okay, along with the advantages and disadvantages. So next we'll see something regarding efficiency, system performance, and user service. So note down these words. So like this can be also one of the important questions in module 1. So efficiency, like indicated by ETA, efficiency, system performance, and user service. So be familiar with these words along with the relevant concepts. I repeat, efficiency, then system performance, and user service. All these three terms are interrelated. Main point here is all these terms, efficiency, system performance, and user service, are interrelated. So suppose if I see the definition of system performance, so this system performance is measured by throughput, and it is always depending upon efficiency eta. So here we have a relation between system performance and efficiency and user service, where system performance is measured by throughput, and it is always depending upon the efficiency. Simple example is, suppose if efficiency is low, so for example, efficiency of any circuit or any design, any model, if I take, okay, so if efficiency is low, so then directly we can say that throughput will be also less. Why? Because this efficiency and throughput are always related to each other. And if efficiency is low, in general, if I say, if efficiency is low, so then throughput will be also low. So for example, if I take, like if we cannot fetch more amount of data from the memory in less time, okay, so then like anybody can say that memory efficiency is less, and also the throughput will be also less. Why? Because here we are achieving lesser frequency. Why? Because we are not able to fetch more amount of data from the memory in lesser time. This means that the memory efficiency or the fetching efficiency of data from memory is less. Hence, obviously, the throughput will be also less. So now let us see the definitions and the related concept of efficiency, system performance, and user service individually. So, but the general points here are So what I can note down from this particular slide is efficiency, system performance, and user service. All these three parameters are interrelated. And if efficiency is low for any circuit, any design, any module, so then throughput will be also less. Okay. So now regarding the term efficiency, so this efficiency of the use of resource is being evaluated by seeing how much of resource is unused or wasted and the amount of resource that is being utilized effectively. So here, based upon the amount of usage of resource and amount of wastage of resource, we can have the evaluation of the word efficiency. Means we can have the check of how much of resource is put into productive use. Okay, among the bunch of resources, right? How much of resources are being effectively utilized and how much of resources are being wasted. So based upon this fact, we can measure the efficiency of the use of resource. So for example, so when computer allocates the resource to the user program, so then how much of the allocated resource are effectively utilized and how much is wasted, right? So to justify this particular sentence, I have taken the example of memory efficiency and CPU efficiency. So like if you look at the memory efficiency means, so this memory efficiency may be low, say if whole memory is not being effectively utilized. Okay, suppose if I allocate 1 MB of memory and if I'm not able to utilize whole 1 MB of memory, then we can say that memory utilization is less. Okay, and in terms of CPU efficiency, so this CPU efficiency may be low if I have a few number of programs in the memory, or our program or our process is spending more time in wasting for input and output operations. Okay, suppose if in the CPU, suppose if in the memory, right, if I have lesser amount of the processor programs, means I'll not be able to keep the CPU very much busy. My aim is to always keep CPU very busy by doing or execution of one or more processes. Okay, so we can't afford to keep the CPU idle. Okay, hence the CPU should be always busy in execution of any program at any instant of time. And if I am able to keep less number of programs in the memory, so then this means that CPU will not be always busy in the execution of the process or programs. Hence, we can say that CPU efficiency will be also low. Okay, so now we can take this example as well. So consider the use of CPU. So the CPU may be doing some useful task. Sometimes if the CPU is idle, this means that so the user program or the process is doing some IO operation. So while any process or any program is doing the IO operation, so this means that CPU is not computing anything, means CPU is kept idle. Why? Because now the process is busy in doing input and output operations. Okay, so like in this case, I can say that CPU is not been efficiently utilized. Why? Because CPU is one of the main resource, and our aim is to keep this main resource, so-called CPU, busy all the time. Okay, so this leads to overhead of the OS operation. Why? Because here I am unable to keep this CPU very much busy. Why? Because one reason may be that I am keeping very few programs in memory. And second reason is if any process or any program is doing some IO operation, so then CPU involvement will not be there. Hence, CPU becomes idle, and that is not acceptable. Okay, hence this will act as a kind of overhead on the OS operations. Second case, OS will also use some of the resources for itself. Why? Because OS is basically the collection of software programs. Hence, this software program also needs some CPU time. Okay, hence, so this OS will be also in need of some resource, so-called CPU time or the memory. Hence, this will act as a overhead. Okay, so this CPU time is utilized, say while we are booting the OS. So while we boot the system, so then OS will be loaded from the ROM to the processor, or to the CPU. So this will act as a kind of overhead for the operating system. Okay. So regarding efficiency, like these are the points. Now moving to the next slide. Let me see that. Yeah, right. So we cannot say that CPU and memory are utilized to 100%. Okay. So why we say that? Because some of the CPU time is wasted when user or process is performing appropriately. Like as I said, when any program or any process is busy in doing the input and output operations, in that case, CPU will not be doing any sort of computation, or CPU will be kept idle. Why? Because our process is busy in performing some input and output operations. So if I say some of the memory is wasted, so for example, like if I need say 1 MB of memory, right? Suppose if I say reserve 1 MB of memory, so for any process, and we are not sure that our process will make use of entire 1 MB of memory. Why? Because nobody can write a program of size exactly 1 MB of memory. Hence, we do expect some wastage of memory. Okay. Why? Because the program size may vary or the process size may vary. Hence, we cannot have, or we cannot say that memory will be utilized to 100%. Okay, so we cannot write a program that needs exactly 1 MB of memory. Hence, obviously, we do have some wastage of memory. Likewise, we do have some wastage of CPU time as well. Why? Because if any process is performing input-output operations, so then CPU will be kept idle. Hence, we cannot say that CPU and memory will be always utilized to the 100%. Second example, say fetching of data from memory, right? So how much of data is fetched from memory, okay, is called as the throughput of memory. Why? Because here the fetching of data from memory is being measured with respect to the time. So whatever factor, whatever parameter that is related to that has been related to time factor, that we call it as throughput. So for example, the fetching data from memory. So for this particular operation, suppose if I'm measuring the amount of data that is being fetched from memory with respect to the time factor, so then this can be called as the throughput of memory fetching. So we can read more data in less time. Suppose if I'm able to have reading of more data in lesser amount of time, means I can say that the throughput is high. Why? Because this particular so-called concept of reading more data is being measured with respect to the time factor. Hence, this corresponds to the high throughput. Okay, so when user needs is to be fulfilled, this in less time. Okay, so whatever the user needs are there, those needs must be fulfilled in less time. Suppose if we're able to achieve this, means I can say the throughput will be high. Okay, so the bottom line is whatever operation, whatever entity that we are discussing, and like if the like operation is being defined with respect to the time, so then that we call it as throughput. And like here I mentioned the throughput of say fetching of data from memory. Okay, so for this operation, if this operation is been measured with respect to the time, so then we can call it as throughput of memory. Okay, so here so whatever like we have discussed here, same thing is been tabulated. Like if I see the efficiency of use, like aspect is there and the means of measurement is here and the description is being mentioned here. Suppose if I'm dealing with efficiency of use, means I can have CPU efficiency and memory efficiency. Like I said, CPU and memory. So we cannot say that CPU and memory will be always utilized to 100%. So why? Because the reasons are being just mentioned here. Okay, so we have something called as CPU efficiency, and this means that percentage utilization of the CPU, and memory efficiency refers to percentage utilization of the memory. Okay, and system performance will be always measured, always related to always related to the throughput parameter. And this throughput is nothing but amount of work done per time. Like as I said, this throughput will be always related to the time factor. Okay, hence the amount of work done per unit time, we call it as throughput. So once I say user service, okay, so once I say user service means here we are going to measure the user service with respect to two parameters. Those are turnaround time, okay, and second one is response time. Okay, remember these words. User service will be measured in terms of turnaround time and response time, where turnaround time is nothing but time to complete a job or a process. Okay, so the time from submission of a job or process to a system, and the difference between the submission of a job to a CPU or processor and till it's completed, completion. So we call it as a turnaround time, or the time to complete a job or a process, we call it as turnaround time. And response time is time to implement one sub request. Okay. So what do you mean by this word sub request is, suppose if I have it's a very big task, okay, a process means I'll be dividing so that whole process into so many sub processes. Okay, so that that can be called as so one sub request. Okay, so basically we measure the user service in terms of turnaround time and response time. Again, we'll see this user service as the third factor. So first we saw this efficiency. Okay, so first we saw the word or the concept efficiency of use of resources. Okay, like that means that how much of resource is being utilized and how much of resource is being wasted. Or so we can have a check of amount of resource that has been put into the productive use, and we cannot say that memory efficiency and CPU efficiency will be always achieved to be 100%. So we have the reason for this also been mentioned here. And second one is the user service. Okay, so this user service is can be defined as the amount of time taken. So the amount of time taken by any user or by any software. So this user service is able to indicate how quickly, how fast a user computation has been completed by the OS. So upon giving a request for any sort of request, say by the user or any software, so then how our OS will be able to give or be able to complete the so-called request. So that particular like fastness, or with the what speed our OS will be able to have the computation to be completed, that can be measured with respect to the user service. For example, if a user requests for memory, then what we expect is so that allocation of memory should be allocated as fast as possible. So then amount of time taken by the operating system to allocate memory for the user, we call it as user service. And if our OS is fast enough to allocate the memory for the user in lesser amount of time, then we can say that user service is appreciable or user service is very good. So this user service can be measured using two like so-called time units according to previous slide. So we can have the measurement of user service in terms of two parameters or two time units. So one we call it as a turnaround time, and second one is response time, as mentioned in this particular slide. Okay, the user service is measured with respect to turnaround time and using the response time. So you can see here this turnaround time is nothing but suppose if I'm performing a job, so then how much time I need to finish the job means the amount of time elapsed or used between submission of a request and the completion of a request. This time difference we call it as turnaround time, or the amount of time used in between submission of a job or a request and completion of request, we call it as a turnaround time. And regarding the response time, say like if I'm